I'm actually going to do everything here from my Kali machine through SSH. That's because I have a shared clipboard between my Kali and my host machine, which means I can copy and paste. I can't actually copy and paste directly to the machine itself. However, I could run the same commands or perform these same steps on the machine itself. It doesn't really make a difference. I just prefer to do it from my Kali machine so I can copy and paste for this demo specifically. All right, taking a look at that auditing commands sheet that I pointed out earlier, the first method we're going to make use of is this bash trap debug method that I already kind of started explaining earlier in this video. So the big point here is we're going to be using that trap command, and we're going to set that trap on debug, so it's going to run whenever a command gets run, and then we can run whatever set of commands we want. Where do we want to put that trap command? Well, the most logical place to put it would be in that bash.bashrc file. Why do we want to put it in bash.bashrc? Because we want that trap to be set every time somebody starts an interactive shell on our machine, whether or not they're logging in. This would make it so that even if the attacker got in through a service user, like www.data, if they got in through a web vulnerability, right? No matter what, if they spawned an interactive terminal session with something like bash, this bash.bashrc is going to get run. So we can put that trap command inside this bash.bashrc. And we're going to do it in the system-wide bash.bashrc so that it doesn't matter how the attacker got in, which user they got in as, no matter what, this is going to get run. So I'm going to go ahead and I'm going to modify. So I'm going to say sudo nano etc bash.bashrc. Sorry, I forgot. In Debian, it's actually called etc bash.bashrc. There we go. And I'm going to first go all the way down to the bottom, and I'm going to add this code here, or these set of commands here at the bottom. Right away, I'm going to write this out. Trap log command debug. So that's going to say I want to run this command whenever we hit that debug signal of sorts, right? However, I don't just want to run a single command, right? I actually want to run a bunch of commands. So how can I do that? Well, I can actually create a function in bash that lets me hold a bunch of different commands. So in this way, I'm going to create a function. I'm going to call it log command. I'm going to define that function here. And then in the end, we're actually going to run that function or that group of commands. So the first thing we want to do is we want to actually get the command that that person is going to run. And the way that we can do that is with fc. So if we take a look at fc, I'm just going to spawn a new terminal window here. It looks like it doesn't have a nice help screen here, but we can probably say man fc. I guess it has no manual entry for it either, but we can always look it up. So the fc command allows you to edit and re-execute commands previously entered to a shell without rewriting them again. So before that command gets executed, we can actually take it and do something with it. So for example, we can then print it to our log file, right? And so with this -ln and -0 flag, that's basically saying, get the command that's about to run, and instead of running it, return it. The next thing we're doing is we're piping that into awk. And what awk is basically doing is it's just cutting off the beginning white space and the end white space. Because if you were to actually, I tried this first with just this, without this awk here. And each of the commands had a bunch of white space before them and a bunch of white space afterwards. And basically what this awk is doing is it's saying get rid of the white space before and the white space after. In the end, we're going to have this command variable. And this command variable is going to hold the actual command that is about to be run. So the first thing I'm going to do is I want to create a variable that's only going to exist inside this function. So I can do that with the declare keyword. So I'll declare a variable called command. Then I'll set command to this right here. That's going to basically run FC to get the command that's about to be run. And it's going to remove any leading or trailing white space. Just like that. And then the next thing we want to do now that we have that command is we want to actually print it to our log file. So I'm going to do that with echo. So along with the command itself, we might want to print out some additional information as well. Because just knowing what commands are being run on our machine is not very helpful. We probably also want to know how the attacker got in, and so we want to know what user they're running the commands as. And probably the process ID that's associated with those commands that they're running, right? Because knowing the process ID, we can actually kill that specific process and kick the attacker out, right? And knowing the user, we have a good sense of how the attacker got in. For example, if the user is www.data, we know that the attacker got in through some kind of web exploit. So why don't we we'll print out the time that the command is run. And that's basically what this date command does here. It prints out the date. This B prints out the month. This D prints out the day. And then we have hours, minutes, and seconds, right? Then from there, I just put this dash to make it more visually appealing. And then this $$ prints out the current process ID. So if I, for example, just echo $, it's going to print out the ID of the current process, right? So then we have that process ID. We're going to run who am I, and we're going to put the result there as well. So that'll tell us which user is running that command. Then we'll print out the pwd environment variable, which basically tells us our current working directory. So if I say echo and I print out this pwd environment variable, that tells us our current directory, and that's essentially the same thing as running the pwd command, right? And then we're going to actually print out that command that we saved to that command variable before. So with just this echo statement, we can print out all that information. So as an example, I'm just going to run it here in my Kali machine. But of course, we actually didn't define command. So command's not going to print anything, but the rest of it will. So as you can see, we printed the date, the process ID, who we are, and the current working directory. So I'm going to go ahead and I'm going to copy and paste that echo statement here. But instead of printing this out, right, because printing it out isn't going to be super helpful to us because that'll just show the attacker the command that they ran, right? Instead, we're going to redirect the output of that with these two greater than symbols, I guess, right arrows. We're going to use those to append, or not overwrite, but add content to a log file, which in this case I'm calling var log commands.log. So this should be all we need in order to get this set up. If I save this, it's there now. The other thing we need to do is we need to actually set up that log file. So if I go to var log, I'm going to create a new file called commands.log. But we have to be very careful about the permissions on that file. We don't want that file to be readable by everybody because then anybody can read the commands that everybody else is running. We don't want that. We only want root to be able to actually read the contents of the file, right? However, we need everybody to be able to write to the file, because that file is written to by whatever user the attacker is going to be running as. So if they're running as www.data and that trap gets called and it tries to write to the file, www.data needs to be able to write to the file. So we need everybody to be able to write to that log file. So I'm going to create that file. I'm going to say touch. I'm prefixing this with sudo so that we can actually create that file as root, so it's owned by root. Commands.log. And then when I'm setting the permissions, I'm going to set the permissions so that root can read and write to the file. So that's 4 plus 2 equals 6. However, anybody else can only write to the file. So that's 4, right? Or sorry, that's 2, right? So 2, 2. And now if I go ahead and I print out the permissions on that file, you'll see that root can both read and write the file. However, everybody else can only write to the file. Okay, here's the second potential problem with this. The second potential problem is if everybody can write to this commands.log file, then anybody can overwrite existing content in that file. That could be a problem because then an attacker could basically cover their tracks by emptying the contents of this commands.log file. So we need a way of allowing everybody to append or add content to the file without allowing them to actually change the content of what's already there. Fortunately, in Linux, there is something that allows us to do this. So along with each file in Linux, along with these permissions, there are additional attributes that affect how the file behaves. We can list attributes with lsattr, or list attributes. So if I say sudo lsattr commands.log, and this lists all of the attributes for the commands.log file. If there is a special attribute called append, if we set the append attribute, then nobody will actually be able to write to the file. They'll only be able to add content to the file or append to the file. They won't be able to overwrite what's already there. So to add that attribute, I can say sudo chattr for change attribute plus a to add the a or append attribute, and then the file, so commands.log. Now if I go ahead and I list the attributes of that file again, you'll see it has that append attribute set. This means that as user, now, I can add content to the file. So for example, I can echo test, and I can append that with those two arrow symbols to the file commands. However, as user, I can't read the file because I don't have read permissions, right? But you'll notice, just to demonstrate that if I try to read the file as root, we can see that I appended test to the file. But if I actually try to overwrite the content of the file, so if I try to overwrite it with, like, I don't know, ABC, this time I added only one arrow to overwrite the file rather than append. If I try to do that, I get operation not permitted. Why? Because that append attribute is set that doesn't let us actually write to the file, but only lets us append to it. Now that this is fully set up, all we have to do is log out and log back in, and any command that we run should be logged to this file. So if I exit out and I log back in, and I run some commands like ls and pwd and who am I, and now if I try to print out the contents of that file, again I need to do that as root because only root can print out the contents of that file. /commands.log. We see all the commands that user ran: ls, pwd, who am I, and even that sudo command that allowed us to view the contents of that file. If we were to switch to another user, like for example, I can switch to the user www.data. Of course, www.data's default shell is not a runnable shell, so I have to explicitly specify the shell I want to use with -s bin bash. And now if I try to run commands as www.data, for example, say ls, who am I, pwd, cat, exit that. Now, if I print out the contents of that log file again, you can see all of the commands that we ran as www.data. The nice thing about this log file is you can filter it just like we filtered all of the other log files that we worked with previously. So if we know, or if we see that the attacker got in as user www.data, we can say grep www.data on that var log commands.log file. And of course I have to prefix this with sudo to do this as root. But then we only get the commands that www.data ran, which is pretty useful for filtering this out. I can also filter out by process ID. So if I want to filter by process ID 17031, same thing. I filtered it out, so only those commands that were ran by www.data were actually displayed. So this is one example of how we can log the commands that every user runs in Linux. And this can give us an idea of what commands an attacker ran when they got onto our machine that allowed them to privilege escalate. The advantage of this method is it prints it out very nice and easily to read, right? This is very easy on the eyes. The second nice thing about this method is we didn't have to install any additional tools to do this. We did this using only commands and files that are actually built into Linux. However, there are a bunch of pitfalls of this method. The first pitfall is it relies on the fact that the attacker is going to use the bash shell. Remember, we put our trap in bash.bashrc, right? However, there are other shells on our machine, like for example, dash, and the attacker could actually get in and choose to use the dash shell rather than the bash shell. And if they choose to use dash, that bash.bashrc file is not going to get run, and the commands that they run will not be logged. That's probably the biggest downfall of this method of logging commands. You could try to circumvent that by limiting what you can do with other shells on your machine. So a lot of the times attackers will either use bin bash or they'll use bin sh. So we can make sure that bin sh points to bash rather than dash. So if an attacker tries to use bin sh, it'll actually cause them to use bash, right? By default, in a lot of newer distributions of Linux, if I take a look at that bin sh, it actually points to dash rather than bash. I want to warn you, though, that if you actually change this link, it does have the potential to break things on your machine. A lot of things that would previously be using the dash shell are going to be using bash. Bash is also slower and it doesn't have the full functionality of dash. So do that at your own risk, right? It might work on different distributions of Linux, and maybe you try it out and you see it does work, but maybe you try it out and you see that it doesn't. On some distributions of Linux, you can even change the shell that your machine uses by default. Like I read, for example, that on Ubuntu, if you say sudo dpkg reconfigure dash, it'll actually give you the option to switch back to using bash as your default shell as opposed to dash. So there are many different ways that we can try to restrict the attacker to using bash rather than any other shell. However, perhaps there's a more foolproof method of doing this that allows us to see what the attacker runs no matter what shell they're using. Or maybe they're not using a shell at all. Maybe they're using some command and control framework that's actually running, that's actually performing function calls or performing syscalls that are directly interacting with the kernel. Basically, they're not using a shell. They're using a command and control framework. Again, this trap method will not necessarily show commands that are being run through a command and control framework, right? So we need a better way of finding the commands that an attacker runs. And that's what brings me to auditing tools, like, for example, Audit-D. There's a lot that you can do with Audit-D other than just listing commands, but we can use Audit-D to see all the commands that are being run on our machine.